Hello everyone, myself Manoj. I'm studying in Sri Venkateswara College of Engineering. Today we're going to discuss about recurrent neural networking using deep learning. A recurrent neural network is a deep learning model that uses the concept of supervised learning. Deep learning belongs to the family of machine learning. It is also called hierarchical learning or deep structured learning. The classic machine learning algorithms are definite, while the deep learning algorithms follow a chain of command. Deep learning has the capability to deal with the more complex neural networks, and it is mainly deals with the sequential data. Recurrent networks can process examples one at a time, preserving an element that reflects over a period of time. Introduction. Recurrent neural network RNNs are class of artificial neural networks designed to recognize patterns in the sequential data such as time series, natural language, and speech. Unlike the traditional feed-forward neural networks, RNNs have connections that form cycles, allowing them to maintain memory for previous inputs. This makes RNN particularly well suited for tasks where content and order of the inputs matter, such as machine translation, speech recognition, and sentiment analysis in an RNN. The output from the previous step is fed as input into the current step, enabling the network to capture temporal dependencies. Methodology. Sequential processing RNN take input data in the sequence and process it by step for each input in the sequence. RNN maintains a hidden state that encapsulates information about the previous inputs. Back propagation through time, BPTT. Training RNNs using variations of a back propagation called back propagation through time BPTT. Here, the errors are propagated through the time steps, meaning that the gradient is computed over the entire sequence rather than individual steps. Variants of RNN. LSTM, short-term memory. It introduces memory cells that can retain the information for longer periods, tackling the vanishing gradient problem common in standard RNSs. GRU, gated recurrent units, similar to the LSTM but the similar structure, offering to an efficient solution for sequential modeling. Benefits of RNN. Handling sequential data, contains prevention, flexible input lengths, language modeling. Coming to the handling sequential data, RNN are one of the few neural networks architectures that can naturally handle sequential data and temporal dependencies. RNN content preservation. RNN are able to retain the information about the previous inputs, which is crucial for the tasks like machine translation or speech recognition. Flexible input lengths. Unlike the traditional models that require a fixed size inputs, RNN can handle variable length sequence, making them ideal for tasks like text generation and time series forecasting. Language modeling. RNN, especially LSTMs and GRUs, are widely used in the language models due to their ability to maintain long-term dependencies and generate coherent states. Disadvantages of using RNN. Vanishing gradient problem. During the back propagation through a time gradient can dismiss, making it difficult update weights effectively, especially for the long sequence. This makes learning difficult for the long-term dependencies. Training complexity. RNN requires significant computations, resources, and time for training due to the sequential nature of the data. Limited memory. Despite the name recurrent, RNN struggle to retain information over the very long sequence without additional mechanism like LSTMs or GRUs. Difficulty in parallelization. RNN process the data step by step, which makes it challenging to the parallelizing the training process compared to the feed-forward neural networks. Scope of RNN, natural language processing. RNN are extensively used for tasks like language modeling, text generation, machine translation, and sentiment analysis. Speech recognition. Many speech to text systems are RNN to convert spoken language into text. Time series forecasting. RNN are used ideally for predicting future values in the time series data, such as stock prices, weather forecasting, and economic indicators. Video processing. RNS can be applied to the video data for tasks like captioning and action recognition by processing of frames sequentially. Healthcare. In this predictive healthcare, RNN can be used to model patients' data and predict health outcomes based on the history of the medical records. Conclusion. Recurrent neural networks have the revolutionaries the way sequential data is processed in the machine learning. Their ability to the handle the temporal dependencies has made them indispensable for the tasks like language modeling, time series forecasting, and speech recognition. While they have some limitations such as vanishing gradient problem and have high computation cost, advancement like LSTMs and GRU have mitigated these issues, allowing RNN to be widely adopted across the industries. As deep learning continues to evolve, RNN will remain a critical tool for solving problems involving sequential data for the temporal patterns. Thank you.